Okay, in this video I'm going to go over some of the problems on the midterm review packet at the end. Okay, so that extra midterm review. So the first problem I'm looking at is on page 27, and this one was similar to one that we did in class. They just did a little twist to it. They are giving us a cylinder with height and radius and the volume. So I would assume they'll probably give you the formulas since the test is going to be free response. But the volume of a cylinder is pi r squared h, so that's 4,000. Then they're saying the material for the top and the bottom. So they're talking about the surface area. So the surface area of a cylinder, there are two circles. So the area is pi r squared for a circle. So we have two of those, 2 pi r squared. And then I always think about it as a soup label. Like if you peel it off, this part is the part that went around the can, which was the circumference. And this is the height. So 2 pi r h. But what they tell us is that the material for the top and bottom is 2 cents. I'm going to let the cost be in cents. And then the size, the material for the side is 1 cent per square centimeter. So I am coming up with my cost formula. Now looking at that, there are too many variables. So I'm going to go back to this pi r squared, h is 4,000. Solve it for h, and then plug in for h 4,000 over pi r squared, so that we can get a cost equation all in terms of the radius. That, believe it or not, is Algebra 2 material. So we get the formula in terms of one variable so that we can do the calculus, which is take the derivative, get our critical numbers. 0, critical number won't make any sense. The only critical number we'll get is the cube root of 1,000 over pi. We can't assume that it's a maximum or a minimum until we test it. The derivative changes from negative to positive, so it was a minimum. So we're going to keep a cube root of 1,000 over pi centimeters. If we plug that back into the height, if it's free response, you could leave it like that. You don't necessarily have to simplify it to get the number of centimeters. Okay, the next one that was asked was number 12. So this one is a 15-foot ladder is leaning against a building, and they give us this ordered pair 0y. The bottom is at x0. The ladder is falling down, so that rate's going to be negative since it's decreasing. So dy dt is going to be negative 12 feet per second at the instant when x is 9. We want to find dx dt at that instant. So I'm going to use the Pythagorean theorem. The length of the ladder never changes. So that's going to be, since it was 9, 12, 15, this is the right triangle at the instant when x is 9. I'm going to take the derivative, 2x dx dt plus 2y dy dt equals 0. When x is 9, dx dt is what we want to find, plus 2, y was 12. It was decreasing at a rate of negative 12 feet per second. We can solve for dx dt, and that's what they were looking for. Okay, the next question was number 17, which was an average value. I don't know if average value is going to be on your test based on what they said, but the formula I would write down on your cheat sheet so you have it handy. 1 over b minus a, the integral from a to b of the function. Now, even if average value isn't on the test, this is still a good one to be able to integrate because we have to know how to integrate it. If u is ln of x, its derivative, 1 over x dx is sitting right there. So we have 1 over a minus 1, which that kind of fell off the page. We're integrating u, so I went through and did that. And then I'm plugging in the limits of integration. So I have 1 over a minus 1, ln of x quantity squared over 2, from a to 1. So I have 1 over a minus 1, ln of a squared over 2 minus ln of 1 squared over 2. We know ln of 1 is 0, so that part's going to go away. And it is going to match up with a. Or I'm not a, sorry, e. A looked good, but it was missing a 2, so it had to be e. All right, the next one was number 22. A rectangle is inscribed in this curve, we want to maximize the area of the rectangle. So when I do these, I always and they did it too. So, this is like your typical X and Y, that ordered pair. So our rectangle is 2x times y. We're going to plug in what they gave us for y to get our area all in terms of one variable. Taking the derivative, this is a really good one to be able to take the derivative of. It's using the product rule. So if you did v u prime plus u, v prime is e to the u times u prime. Now we notice, hopefully, because we want to set this equal to 0, that there is a GCF, 2e to the negative x squared, which we can take out. We're left with negative 2x squared plus 1. This is a step that students typically have really difficult time doing. Remember, we did that really difficult one from, I think, the 2007 exam that students couldn't solve. Because what happens is you're going to take this and set it to 0, and we need to make sure that we know that e to anything is never going to be equal to 0. There's a horizontal asymptote. We're going to solve the other. Get x is positive and negative 1 over root 2. That picture is symmetric, so I'm only going to test one of them just to make sure it truly was a maximum. Once I get the x value, I can find the y, and then they want the maximum area. If it were free response, we just have to leave it like that. This one was a calculator problem, which they didn't adhere to the 3 decimal places. Our answer should be 0.858. Okay, the next one was 23. They give us the velocity and they want the total distance. This is a formula we want to make sure we have written on our cheat sheets. We have to make sure we're integrating the absolute value of the velocity to get the total distance. And then this was a calculator question, so that's all we'd do. But since your test is free response, I'm going to bet that they might test you on what happens here. So what we'd have to figure out is with this function, when it changes direction. So when that function is equal to 0. Now 0 is not going to really help us because it starts at t equals 0. So it's not going to change direction then. But if we went through and solved it, sine t squared equals 0. We know that we're going to get t squared is 0 at, the sine is 0 at every interval of 0, pi, 2 pi, and so on. So when we solve that, we'll get the square root of pi, square root of 2 pi, which is going to be out of our interval. So I tested the square root of pi. That's when it changes direction. So it's going to move to the right from 0 to root pi, then to the left from root pi to root 2 pi. So if I had to set that up, I would make it a negative integral because I know the integral is going to give me a negative, and a negative times a negative would be positive. Oh, and then root 2 pi was in that interval actually. It just went off my screen. So root 2 pi I know is going to be moving to the right, so it's going to be a positive, so I don't have to fix that in any way. So if I had to do the long way to do it, that's how I would do that. Changing direction, you want to check critical numbers, test to see when the particle's moving left or right. Anytime it's moving left or down, it would be a negative. Okay, 24 asks for the linear approximation. It's basically using the equation of the tangent line at 0.5 is what we want to find in the end. So I'm going to find the equation of the tangent line to this function at x equals 1. When x is 1, I could find the y value. The derivative at 1 is my slope of my tangent line. Then I'm going to use point slope, putting in the slope that we just got of negative 1 over e and the point 1 comma 1 over e. So my y equals is basically this negative 1 over e times the quantity x minus 1, and then I want to add the 1 over e so that I have y equals, or this is L of x instead of y, equals negative 1 over e x plus 1 over e plus another 1 over e. And then I'm going to use that equation, putting in a 0.5 to approximate what the y value would be. Okay, and I believe those were the last questions that were asked. So if you have any other questions,